Hello, welcome to the lecture on section 2.1 through 2.2. Originally I had it as 2.1 to 2.3, but I just feel like that might be a little too much to cover for one night. We'll just do 2.1 to 2.2. The other thing that's going to be different about this video is that I already did the video, but unfortunately YouTube thought my video was too long and rejected it. As you can tell probably by the tone of my voice, I'm not a happy camper right now. so we're just going to have to look at the notes I wrote and kind of just talk about it. I could rewrite the notes, but I think it'll just take a while. So I'm just going to kind of just recap the notes I did about a half hour ago, as you see right here, and kind of just scroll through it and just talk about all these different things. So starting with section 2.1, that's about relations and functions. And as you see here, a relation is a pairing of input values x with output values y. So it's just a chance for you to pair x and y values. That's it. So you can see here, and I could probably use the highlighter to do some of the stuff. So as you can see right here, that's a relation because you have a table with x and y. That's a relation because you have a coordinate plane that plots x and y values. So again, a relation is very simple, just a pairing of input values, or x, with output values, y. A function is going to be a relation in which each input has exactly one output. So each x value has just one y value. So if you see an x value show up more than once, that's not okay. As you see here, you see how y shows up twice, and of course there's two different y values, 2 and 4. That's not a function. This is okay because all these right here are different. Another way to look or to determine if a relation is a function is applying the vertical line test. The way the vertical line tests work, if you have a parabola or any kind of graph or whatever, draw vertical lines. If the vertical line touches the graph no more than once, so I emphasize no more, then you have yourself a function. So notice how all these vertical lines, these blue lines, cross the graph just once. If it crosses more than once, then it's not a function. Like you see here, this vertical line crosses the graph more than once. If you were to plot points or assign points like 1, 2, 1, -2, obviously there's more than, the x value 1 has more than one y value. That's not okay. Also in section 2.1, we want to discuss graphing of lines. So in this case, y equals x plus 2. If you make a t-table or xy table, and you can make up any value you want for x, like 0, 1, and 2. The y values are 2, 3, and 4. I just plug them in. Plug in 0, you get 2. Plug in 1, you get 3. Plug in 2, you get 4. Plot the points, draw a line through them. Very simple. What we just graphed actually was a linear function. Linear function is usually written in this format, y equals mx plus b. We'll discuss what m and b are a little bit later. Actually, I won't discuss what b is, but I will discuss what m is in section 2.2. Or if you don't see an exponent showing, so like the exponents for x and y are both 1, we don't show them, that'll be linear. So y equals x 3x plus 5, that's a linear function. This is not because of that right there. The x square prevents this graph from being a line, therefore it's not linear, not a line. So that's section 2.1. For section 2.2, that deals with slope and rate of change. That's a very important concept. And slope can be defined as rise over run, or change in y over change in x. The letter we use to represent slope is m, usually. And the calculation is simple. y2 minus y1 over x2 minus x1. So if you plot these points here, so for example, if I use my pen, this is x1, y1, that's x2, y2. And you can see also I labeled it x1, x2, y1, y2. So this represents the difference in the x values, x2 minus x1. This represents the difference in the y values, y2 minus y1. And then you just divide the rise, which is this, over the run, which is that, x2 minus x1. So, for example, find the slope of a line that passes through the points -1, 3 and 2, -1. So you take the change in y values, which is -1 minus 3 or -4, take change in x values, 2 minus -1, and you get -4 over 3. And you can see right here, by plotting the points, the first point, -1, 3, we go down 4, and then to the right by 3. That explains why we have -4 over 3. We also want to talk about zero slope and undefined slope. Zero slope happens when you have a horizontal line. Undefined slope happens when you have a vertical line. The reason why that's the case is because if you have a horizontal line, the y values will be the same. So when the y values are the same, the numerator is 0. 0 divided by anything is always 0, hence zero slope. If you look at this example, 2 minus 2, 0, over 3 minus 1, 2, so you get 0. For undefined slope, that's when the x values are the same. See here we have 1 and 1. So in the bottom you got 0. The top, it doesn't really matter, because anything divided by 0 is impossible, so that's why it's undefined. And we see by plotting the points for the horizontal and vertical lines, the lines look like the way they should. Lastly, we talk about parallel and perpendicular lines. Parallel lines is when you have two lines of the plane that never cross, right? Perpendicular lines, two lines that form a 90-degree angle with each other. We tend to use this symbol to represent parallel lines, and this symbol to represent perpendicular lines. If two lines are parallel, the slopes will always be the same because they both rise and run the same way. Otherwise, they would wind up touching each other, right? So if they never touch, they're parallel, same slope. Perpendicular lines have opposite reciprocal slopes. What that means is that you take the slope of one line, if you were to flip that slope over, or just take the reciprocal, and then change the sign from positive, negative, negative, positive, you will have the slope of the perpendicular line. So look at here, m equals 2. So I flip over 2, becomes 1/2, but then change the sign, -1/2. So for example, determine if the lines are parallel, perpendicular, or neither. So you have 2 points for line 1, 2 points for line 2, so we must calculate the slope for each one. The slope for line 1 will be 6 minus 2 over 3 minus 1, which gets us 2. For the other one, it will be -1 minus 0 over 0. Ooh, good thing I went over this again. 0 minus -2. Okay, so maybe it's a blessing in disguise that my video didn't get uploaded the first time. So that becomes actually 0 plus 2. So that's still fine. We still get -1/2. And clearly these slopes are opposite reciprocals of each other. They're not equal, but they are opposite reciprocals. Therefore, it's perpendicular. So hopefully this kind of covers some of the important things from 2.1 and 2.2. We will do some problems with this in class next time we meet, and we will move forward 2.3 and 2.4 on the next video. My apologies for posting this late. The internet was down, And then unfortunately I didn't know that if I made a 20-minute video, YouTube wouldn't accept it. So what are you going to do? But have a good night, and I'll see you guys tomorrow or Thursday.